For millennia, humanity gazed at the stars and wondered, are we alone? The vastness of space seemed an insurmountable barrier. Yet, in the last 3 decades, our understanding of the cosmos has been revolutionized. We've entered the era of exoplanet discovery. Powerful telescopes, both on Earth and in space, have revealed thousands of planets orbiting distant stars. Initially, most exoplanet discoveries were gas giants like Jupiter, orbiting close to their stars. These hot Jupiters were relatively easy to detect, but unlikely to harbor life. However, as technology advanced, we began finding smaller, rocky planets. Planets more like our own. The search for these Goldilocks planets, those not too hot and not too cold but just right for life, has become a driving force in astronomy. Among the thousands of exoplanets discovered, a few stand out as particularly promising. One such planet is Gliese 667 cc, a world that has captured the attention of scientists and space enthusiasts alike. This proximity, in astronomical terms, makes Gliese 667 cc a prime target for further study and fuels the hope that we might one day detect signs of life on this distant world. To understand the potential of Gliese 667 cc, we must first examine its host star. Gliese 667 c is a red dwarf, a type of star much smaller and cooler than our Sun. Red dwarfs are the most common type of star in the Milky Way galaxy, making up about 85% of the stellar population. While our Sun blazes with a bright yellow light, Gliese 667 c emits a faint red glow, significantly less luminous than our star. This difference in luminosity has a profound impact on the habitable zone around Gliese 667 c. The habitable zone, also known as the Goldilocks zone, is the region around a star where temperatures are just right for liquid water to exist on the surface of a planet. Because red dwarfs are cooler than our Sun, their habitable zones are located much closer in. In the case of Gliese 667 c, the habitable zone is thought to extend from roughly 0.11 to 0.23 astronomical units from the star. This means that planets within the habitable zone of Gliese 667 c orbit their star much closer than Mercury orbits the Sun. While the close proximity of the habitable zone might seem like a recipe for scorching heat, remember that Gliese 667 c is significantly cooler than our Sun. Therefore, planets in the habitable zone of this red dwarf receive less radiation, making liquid water on their surfaces a real possibility. Gliese 667 cc is a fascinating world that has piqued the curiosity of astronomers worldwide. This super-Earth, with a mass estimated to be around 3.7 times that of our planet, orbits its host star within the habitable zone. This discovery, made in 2011, sent ripples of excitement through the scientific community. Here was a planet, larger than Earth but smaller than Neptune, located within the habitable zone of a nearby star. Could this be a true Earth twin? The orbital period of Gliese 667 cc is another intriguing characteristic. It completes one orbit around its host star in approximately 28 Earth days. While this close orbit places Gliese 667 cc within the habitable zone, it also leads to some unique and potentially challenging conditions. Despite these challenges, the discovery of a super-Earth like Gliese 667 cc within the habitable zone of a nearby star is a significant event. Comparing Earth and Gliese 667 cc reveals intriguing similarities and stark differences. Both planets reside within the habitable zones of their respective stars, raising the tantalizing possibility of liquid water existing on their surfaces. This shared characteristic is a fundamental requirement for life as we know it, making both Earth and Gliese 667 cc objects of intense scientific interest. However, despite residing within their respective habitable zones, the two planets differ significantly in their physical characteristics. Earth, with its vibrant blue oceans, swirling white clouds and lush green continents, stands in stark contrast to the likely appearance of Gliese 667 cc. The super-Earth is likely tidally locked to its star, meaning that one side of the planet perpetually faces the star, while the other side remains shrouded in perpetual darkness. This phenomenon could lead to extreme temperature differences between the two hemispheres, potentially creating a planet with a scorching hot day side and a frigid, icy night side. Another significant difference lies in their atmospheres. The atmospheric composition of Gliese 667 cc remains a mystery. The presence and composition of an atmosphere can make or break a planet's chances of hosting life. For Gliese 667 cc, this remains one of the biggest unknowns. We don't yet have the technological capability to directly observe the planet's atmosphere. However, scientists can make educated guesses based on various factors such as the planet's mass, density, and distance from its star. One possibility is that Gliese 667 cc possesses a thick, dense atmosphere composed primarily of carbon dioxide. Such an atmosphere could trap heat, leading to a runaway greenhouse effect similar to what we see on Venus. This scenario would make the planet inhospitable to life as we know it. On the other hand, Gliese 667 cc could have a thinner atmosphere, perhaps even one more similar to Earth's. Such an atmosphere could allow for more temperate conditions, potentially allowing liquid water to exist on the surface. Ultimately, the question of whether Gliese 667 cc has an atmosphere and what it might be composed of remains a tantalizing mystery. The close proximity of Gliese 667 cc to its host star gives rise to a fascinating phenomenon known as tidal locking. This occurs when the gravitational forces between two celestial bodies, such as a planet and its star, synchronize the planet's rotation with its orbital period. In simpler terms, it means that one side of the planet always faces the star, while the other side always faces away. Tidal locking has profound implications for the potential habitability of a planet. On a tidally locked planet like Gliese 667 cc, one hemisphere experiences perpetual daylight while the other is shrouded in eternal night. This extreme temperature difference between the two sides could lead to dramatic weather patterns, potentially including powerful storms and supersonic winds. The side facing the star would likely experience scorching temperatures, potentially hot enough to boil away any liquid water. Conversely, the dark side would be frigid and likely covered in ice. While the challenges for life on Gliese 667 cc are significant, it's essential to remember that life is incredibly resilient. It has found a way to thrive in the most extreme environments on Earth, from the frigid depths of the ocean floor to the scorching heat of volcanic vents. Therefore, it's not unreasonable to speculate that life, perhaps in forms we can't even imagine, could exist on this distant world. The search for life beyond Earth is one of the most profound scientific endeavors of our time. While we have yet to find definitive evidence of extraterrestrial life, discoveries like Gliese 667 cc provide a glimmer of hope. Future missions and observations will undoubtedly reveal even more about this intriguing planet. While the potential for life on Gliese 667 cc is still under debate, its discovery has far-reaching implications for our understanding of the universe. The fact that such a planet exists, orbiting a nearby star within the habitable zone, suggests that such worlds may be relatively common. If we find that Gliese 667 cc is habitable, it could become a prime target for future interstellar missions. While the technology for interstellar travel is still in its infancy, the discovery of potentially habitable worlds like Gliese 667 cc provides a powerful incentive for its development. The potential rewards of reaching another habitable world, of perhaps making contact with extraterrestrial life, make the pursuit of interstellar travel a compelling endeavor. The discovery of Gliese 667 cc and other exoplanets like it has ushered in a new era of exploration. We are no longer limited to speculating about the possibility of other worlds. We can now observe them, study them, and learn from them. While many questions about Gliese 667 cc remain unanswered, its discovery serves as a powerful reminder that we are part of a vast and awe-inspiring universe. As we continue to explore the cosmos, we are sure to encounter even more intriguing worlds, each with its own unique story to tell. The universe beckons, and the search for life beyond Earth continues.